Welcome back guys, I'm Sam and in this Python tutorial you are going to learn everything you need to know to start programming in Python. If you want to learn Python programming language for data science, machine learning or web development, this is the tutorial for you. This tutorial is the perfect place to start learning. In this Python tutorial you're going to learn everything you need to know to start programming in Python. You do not need any prior knowledge in Python or programming in general. I'm going to teach you everything from scratch. If you are new here, make sure you subscribe as I upload new videos every week. Before we get started, let me give you some ideas of what you can do with Python. You can use Python for machine learning and AI. Python is the #1 programming language for data science analysis. And you can also use Python for web development using a framework called Django. Here are 5 websites that are built with Python: YouTube, Instagram, Dropbox, Pinterest, and Spotify. You can also use Python to automate large tasks, so Python can make you more efficient and make your work easier. So now tell me, why are you learning Python? Put it down in the comments below and let's get started with your journey with Python. Now the first thing I want you to do is download the latest version of Python. So just right here, you click on it, you can see it right here, it's downloading. The next thing you're going to do is you're going to click on the downloaded file, and you have to make sure, if you're using Windows as I am using, that you click on add Python 3.9 to path. If you don't do this, what we're doing right here is not going to work. I already have Python, so I'm not going to click on the install now button, but you should click on the install now button and install it. Next, you need to download a code editor. We use a code editor to write and execute our code. The most popular code editor is PyCharm, and you can get PyCharm when you just click on Google PyCharm. You will get it there. PyCharm is a JetBrains product, and all we need to do here is click download. And when we get to this side, you'll see two options. We have the professional and we have the community. And you can also see here we have Windows, Mac, and Linux. Choose the type of computer, but most of the time automatically it takes you to your type of computer. I'm using the Windows, that's why I'm on the Windows section, and then you click on the download for community. We're not going to be using the professional. As you can see, the community is free and it's also open source. When the download is completed, go to your downloads folder and execute the folder. Click on the downloaded folder. As we can see here, it's setting up. And then we get this window here. It says, do you want this app to make changes? You click yes, of course. And now we can see our installation wizard. So we do next, set the location we want to install it. And here you can see you choose the destination of the folder. And here you should add launchers directly path. And then you click on the install. I already installed it, so I'm not going to click on the install. When you're finished with this, you should see a place where you just choose the default settings. And when you choose the default settings, your PyCharm will ask you for your first project to be done. This is how we create a new project in Python. We can see the location of the project and then we give it a name. I'm going to give it a name of what's up. And then we create our file. Act on this window, say yes. And now we'll wait for our virtual environment to be created. Here you can read some of the tips, especially if you're a newbie. It is good to know some of the tips, but in our case, we're going to skip the tips and actually close it. Now we can see our Python file. When we click on it, you can see we only have VEN, which means virtual environment. We are going to talk about virtual environments in the future, but for now, what we're going to do is right click on our project and we click on File. And we can say a Python file. And when we click on Python file, we'll give it a name. I will call mine main. And now you can see we have Python. We have main.python. Now let's write our first Python program. We start with the word print. all lowercase, then a parenthesis, and inside the parenthesis, we can have single or we can also have double quotes. And then we put ready to learn. And you can see here, this is called a string. A string means a string or sequence of characters. In layman's term, it is just textual data. As you can see, this print here is a function, and its function is to print out whatever is inside its parenthesis. So in Python and in other programming languages, whenever we're dealing with text, we should always surround them with single or double quotes. Now, how do we run this code? We run this code by clicking on Run, and then we click on this icon here called Run. And you can also see the shortcut Alt-Shift F10. When we click on it, it asks us what file do we want to run, and in this case, we want to run main. Now we can see Ready to Learn printed on our terminal window. Now, when you get more advanced in Python, you will learn how to use graphical user interface, but as I said, this is an advanced topic and we're not going to deal with that in this tutorial here. So now let's get to the next topic. Alright, now let's talk about variables. Variables are used to temporarily store data in the computer's memory. Examples of variables are somebody's name, somebody's email, a price of a product. Let me show you how a variable looks like in Python. When we declare a variable, we start by giving it a name, age. Then we add an equal sign, and then we type the value, let's say 25. With this, we are storing the number 25 here, somewhere in our computer's memory, and we're attaching this age here as a label for the memory location. Now we can read the value at this memory location and print it out on the terminal. So instead of printing what is your willingness to learn, we want to print the value of the variable called age. Note that when I write age, I do not put it in quotes because this would print the text age, but we want the value that is attached to age. Note that when I also type age, I do not use a small letter h because Python is case sensitive. It doesn't know what this age with a small letter a is. It only knows age with a capital letter A. So I have to change this to capital. And then we can see that the red line underneath has disappeared because now it knows what I'm talking about. Now here on the toolbar, you can click on this play icon. And as you see here, it says run main. And what is main? Main is the name of this file right here, which our program is contained in. And there's also a shortcut, which is Alt-Shift F10. Here we go. We can see the value of the variable name age, which is 25 right here. Now we can also change the value of the variable. For example, on line 2, we can set age to be equal to 55. Now we run our program and we see that age is equal to 55. The value of age is 55. And why this is important is that we can see that our program gets executed from top to bottom. Now let's look at a few more examples. I'm going to declare another variable. I'm going to call this height. I'm going to call this new variable height, and I'm going to give this variable called height a value of 6.3. In Python, we can use numbers with a decimal point or whole numbers. We can also declare a variable and assign it to a string, like we're going to do right now. So we'll say last name, this, which is last name, to a string. We can use single quotes or double quotes. And we set this to Joshua. We also have a special value called a Boolean value, which can be true or false. That is like yes or no in English. Let me show you. I am first going to declare a variable called are you learning? And I'll set are you learning to true. We could also set it to false. What we have here is called a Boolean value. Now note, Python is a case-sensitive language, meaning it is sensitive to lowercase and uppercase letters. We change this to a lowercase true, and we see that it's not the same like with an uppercase. We see there's no error when we do with a capital F, but when it's a small case f, we see the error showing up again. The false or the true with a capital F or T is a special keyword in Python that represents the Boolean false value or the Boolean true value. So this is how we declare and use variables in Python. In this tutorial, I'm going to show you how to receive inputs from the user. In Python, we have another built-in function called input. We use this input function to read a value from the terminal window. Let me show you. We add parentheses and then a single or double quote. Then we type a string. Here we can type a message like, what is your name? How old are you? We'll use what is your name? And we use a question mark and a space. You will see why we use the space in a second. So let us run this program. Now you can see that the character is separated from the question mark. This is because of the white space we added here. Now we have to type a value, let's say Sam. When we press enter, this function will return the value that we entered in the terminal window, so we can get that value and store it into a variable. And we can do that like this. Let's declare a variable called name, and we set it to the return value of the input function. Now we can print a greeting message for this user. To do that, print parenthesis and a string, what's up? We add a space. Now after the string, you want to add the value of the name variable. To do that, we use a plus sign and then type name. What we're doing here is called string concatenation. We are combining this string with another string. Now let's run our program and see what happens. What is your name? Put Sam. And we get here, what's up, Sam? There you go. This is how we use the input function in Python. You have learned about the three types of data in Python. We have numbers, strings, and booleans. Now there are times you want to convert the value of a variable from one type to another. Let me show you. First, we're going to use our input function to read the user's birth year. Say input with a string. I'll say enter your birth year. Now this input function is going to return a value, so we can store it in a variable called birth year. And I'll use the camel notation. Now let's write code to calculate the age of this user. So we write an expression like currently we're in 2021 minus birth year. This expression or piece of code is going to produce a value. So once again, we can store that value in a variable. Let's call that variable age. Now let's print age on the terminal window. Let's run our program and see what happens when the year is 1995. Whoops, we get an error here with an error message. get used to error messages and understand how to read them. Let's go through them. Whenever you see a red message, that indicates an error. This error occurs in this file, which is tutorial/main.py, this file called main.py, which is here, main.py, on line 2, as it's indicated here. Below that, you can see the piece of code that has generated this error, which is this right here. And below this right here, we can see the type of error called type error. It says unsupported operand types for subtraction, int, and str. Well, this int is short for integer, and that represents a whole number in Python. So 2021 is an example of an integer. Now birth year is an example of a string, because whenever we call the input function, this function will return a value as a string, even if we enter a number in. When I enter 1995, this input returned a string with these characters. They are completely different from this here, 1995, the number. They are completely different types. So this string is different from the number 1995. So in this case, let me delete these lines. The reason we got this error is that we tried to subtract 2021 minus the string 1995. Now Python doesn't know how to subtract a string from an integer. So to solve this problem, we need to convert this string to an integer in Python. We have a bunch of built-in functions for converting the types of our variable. So we have this function we can pass here to it, and it will return a representation of the birth year. So to solve this problem, what we do is we need to convert the birth year into an integer. And we do that by using the int function. So right now what happens is that we get a string. Birth year becomes a string right here, a numerical string. And then we convert that numerical string into an integer. And after converting the integer, we subtract it from 2021, which is this year, and we store it in our variable name called age. And after that, we print age. Now let's run it and see what happens. Put 1995, and we get 26. Now we also have another built-in function called float. This float function is used for converting a value into a floating point number. A floating point number in Python and in any programming language is a number with a decimal point. 30 is an integer, and 30.6 is a float. So we have int, we also have float, we have bool for converting a value into a boolean, and we also have stir for converting a value into a string. So these are the built-in functions for converting the type of our variables. In this tutorial, I'm going to show you a lot of dope stuff you can do with Python. Let's start by declaring a variable called tutorial and set it to Python crash course. Now this string here is technically an object. And an object in Python is like an object in the real world. But think of the remote control of your TV. This remote control is an object and it has a lot of capabilities. It has a lot of buttons for turning on your TV and also turning off your TV. Now in this program, this tutorial variable is storing a string object. This string object has a bunch of capabilities. So if we type up tutorial dot, you can see all the capabilities that is available in a string object. These are basically functions that you can call, just like the print or the input functions. The difference is that the print and input functions are general purpose functions. They don't belong to a particular object. But the functions you see over here are specific to strings. And more correctly, we refer to these as methods. So when a function is part of an object, we refer to that function as a method. So let's look at some example. Here we have a method or a function called upper, and we use this method to convert a string to uppercase. So if we print upper tutorial.upper and we run it right here, we get Python crash course. We get it all in uppercase. Now what you need to understand here is that this upper method does not change our original string. It will return a new string. So right after it, if we print tutorial and run it again, we can see that our tutorial variable is still the same. And so we can see here that our the upper function does not change our tutorial variable. It returns a new variable. And similarly to dot upper, we have dot lower for converting our string to all lower cases. We also have find for finding specific characters our tutorial string contains. For example, we can type R and it will give us the first index that R appears on this string right here. It shows us 8. And we can count it 0, 1, 2, 3, 4, 5, 6, 7, 8. And if you notice here, this white space also counts as a string. So in Python, the index of the first character of a string is 0. And if I put a capital R, as we said earlier, Python is case sensitive, we get -1 because it's basically telling us that there is no capital R in this, returned false. We can also pass a sequence of characters like thon, and you can see here returns 2 because 0, 1, 2, and we started with a T here. Now there are times you want to replace something in a string with something else, and we do that with the replace function. We start by giving it the part of the string we want to replace it with. In our case, we say crash, and then we give it as an argument what we want to replace it with, and I'll say 3, the string 3. And let us run this and see. Now tutorial prints Python 3 course. You can see that right here. And obviously, if you look for a character or a sequence of character that is not contained in our string, nothing will happen. For example, if you want to replace crash with Z here, and we don't have any Z here, nothing happens. As we can see here, still the same. And also, just like the upper or the lower function, the replace function is not modifying our string. It's creating a new one. It's going to return a new string. This is because strings in Python and also a lot of programming languages are immutable, meaning we cannot change them once we've created them. Whenever we want to change a string, we always end up with a new string object in memory. The last thing I'm going to cover on strings. So in Python, we can also use the in operator. So we can write an expression like this. And we do that by writing the word we want to check if it's in our tutorial variable. So in our case, it's or with in, and this is a reserved keyword in Python. It's an operator. Type our string here, and then we use the in operator, and then we type the variable we want to check if it contains this. And in our case, it's tutorial. We run it and it says true. So now we know that course is in tutorial. Now let me remove the E and do the same thing. We can see, oh, this is in it. So you can see here that until we put something that's not at all in it, then we get the false, like in our case, X. So with this expression here, we're checking to see if we have course in tutorial. As you can see here, Python code is very readable. It's like plain English. In this tutorial, we're talking about arithmetic operators. These are the same arithmetic operators we have in mathematics. So for example, you can add, you can divide, you can multiply, and so on. Let me show you. You can say here 30 plus 7. And when we run this, we get 37 because this is the addition operator. We can also subtract. We can multiply with this star. And we have two types of division operator. We have this and we have this too. So let's see what happens when I use the first one. When I use the first one, what you can see here is that we get a floating point value. And we know we talked about floating point values earlier. These are values that have a decimal point. And when we use the double, we get an integer. We also have the modulo operator, which is indicated by the percentage sign, and this gives us the remainder of any value. Right now we can type it here, and we get 2, because 2 is the remainder of 30 divided by 7. And we also have the exponent operator, which is indicated by 2 stars, and this basically says 30 to the power of 7. And when we run this, we get this large value. And finally, we have the exponent operator, which is indicated by 2 asterisks, and this is basically 30 to the power of 7. And when we click on that, we get this large value right here. Well, let's do something that we know the answer for. 10 to the power of 2. And we can see here, we get 100. Let's say we have a value of x. Let's say we have a variable of x and want to give it a value of 20. And we want to increment x by 5. What we'd say is, x is equal to x plus 5. And what Python does is it adds 5 to x, and then what we do next is we store that value into x. So that's what this expression is saying right here, is we add 5, we increment x, and then we store it into x. Now, there is another way to achieve this same result using less code. And we do that by saying x plus equals 5. X plus equals 5. And what we have on line 3 is exactly identical to what we have on line 2. And what we have right here is called the augmented assignment operator. You're going to use this a lot. So we have this assignment operator, but we've augmented or we've enhanced it with this addition operator. And we can also do subtract. We can also do multiply. We can also do divide. Now let me ask you a question. I have a variable name called x and I set it to 3 plus 10 multiplied by 2. What do you think the answer of this is? Pause a moment and tell me the answer of this expression. This is a basic math question that a lot of people fail to answer. The answer here is 23. Here is the reason. In math, we have this concept called operator precedence, and that determines the order in which these operators are applied. So multiplication and division have an higher order, meaning this part of the expression gets evaluated first. So in here, 10 times 2, which is equals to 20, and then the result of this is added to 3. That is why the result of this expression here is 23. Now in Python, operator precedence is exactly like in math, but we can always change it using parentheses. We can put them into parentheses, like here right now. Print x, we'll get 26 because it adds 10 to 3 first, and then which is 13, and then it multiplies it by 2, which is 26. So you learned about the arithmetic operators in Python. Now in Python, we have another set of operators called the comparison operators. We use these operators to compare values. Let me show you. 5 is greater than 3. So what we have here, this expression is called a Boolean expression because it produces a Boolean value. So in this case, because 5 is greater than 3, the result of this Boolean is true. And we can see that by printing y. And you can see here, we get true. So here is the greater than operator. We also have greater than or equals to. We have less than or less than or equals to. And here is also the equality operator, which is denoted by two equal signs. Do not confuse this with the assignment operator. They're totally different because here we're comparing 5 and 3 for equality. Therefore, if we run our program, we see false because 5 does not equal to 3. But we also have the not equality operator that is indicated by an exclamation mark followed by an equal sign. Here are the comparison operators we have in Python. We have greater than, we have less than, we have greater than or equals to, we have less than or equals to, we have the equality operator, and finally we have the not equal operator. So these are all important, and this will be used in your Python programs a lot because very often we have to compare values to evaluate certain conditions. And for sure you will see that very soon. In Python, we have another set of operations called logical operations. We use these operations to build complex rules and conditions. Now let me show you. I'm going to create a variable called price and give it a value of 10. And I'm going to print price is less than 5. Now, if we wanted to see if this price is between 5 and 15, this is where we use the logical AND operator. The way we do it is we type and right after and we type another Boolean expression. We change this to greater than, and we say price less than 15. And when we run it, we see true. So in this AND operator, if both these Boolean operators right here return true, then the result will be true. If one returns true and the other returns false, then the result will be false. And if none return true, the result will still be false. So it is only true when both are true. This is the AND operator. We also have the OR operator. With the OR operator, if if at least one of these Boolean operator, either this or this, returns true, then the entire expression will return true. If both return true, and that's why I said at least one, that means both can be true, it will still return true. If neither is true, then it will return false. To demonstrate this OR operator, I'm going to change the value of price to 3. So it's first going to check here and say, is price greater than 5? The answer is no. But then it's also going to check this, is price less than 15? And the answer is yes. So when we run it, we get yes. The next one we have is the not operator, which basically inverses any expression it's giving. And let me show you that. Right here we have one Boolean expression which says price is greater than 5. And this expression right here is false. When we put the not operator, it's going to inverse this false expression to true. Let me show you. You can see right here we get true. Now let's summarize what we just learned. In Python, we have 3 logical operators. We have AND, which returns true if both of the expressions are true. We have OR, which returns true if at least one of the expression is true. And we have NOT, which inverses any value that we give it. In this tutorial, we're going to talk about if statements in Python. For example, we can declare a variable called temperature, and depending on the value of this variable called temperature, we can print different messages on our terminal. Let me show you what I'm talking about. Here's our temperature variable, and we set it to 40. Now, let's say that if temperature is greater than 40, we want a message to be printed that says it's a very hot day. So we type if, then we type a condition, and this is where we use our comparison operators. Temperature is greater than 40, then we type then with a semicolon, and pay attention to what happens when I press the enter button. The character is indented, and this indentation represents a block of code. So the code that we write over here will be executed if this condition right here is true. Otherwise, it will not be executed. Let me show you. We're going to print it's a very hot day. Notice that I didn't use a single quote because we're using this apostrophe right here. So if I use a single quote, Python thinks that this is the end of this string and it doesn't know what this right here is. So that's why we're seeing the error sign. So this is why in cases where you need to use apostrophes, you use the double quotes. This means that any code we write right here will always get executed whenever this condition right here is true. So here we can write another message saying go to the beach. I live in Spain, so that's why I always go to the beach when it's very hot, especially above this. To terminate this indentation, we press Enter and Shift and Tab. We can see right now that it is no longer indented. And this means that the code that we write here will always get executed no matter what happens. It is outside the if statement. In JavaScript, you will notice that we use curly brackets or curly braces, and these are used to represent indentation, like in Python that we're doing right now. A question I have is this going to run? Take a pause and answer that. And when I run it, we see nothing happens. Why is that? Because temperature is 40 and our statement says if temperature is greater than 40. And in this case, temperature is not greater than 40. If we change temperature to 45, then we see our message right here, and it says it's a very hot day, go to the beach. Now after this block, let's print finished. I will put this to 35. We can see right here, finish gets executed, but the code in our if statement does not, because temperature is 35 and 35 is not greater than 40. Hope that makes sense. As we said earlier, this will execute even if this if statement gets executed. So right now, I'll change our temperature back to 45, which is greater than 40, and you see we get all three messages. We get it's very hot, it's a very hot day, go to the beach, and then finish. Now I want to add another condition. I want that condition to be if temperature is between 25 and 40, I want there to be a message that says it's a nice day. To do that, we type elif, which is short for else if, and after elif, we type the second condition. So temperature greater than 25, and we add a colon and press enter, and we can see the indentation again. We can print here, I love the weather today. Now if this condition is true, that means our temperature is greater than 25, but also less than 40. Python is not going to execute this. Whenever we type a pound sign, which is this right here, Python knows this is a comment. Now let's run our program and see what happens. We can see the temperature is 30, and we have this condition right here which says if temperature is greater than 25, then print this right here. And we can see our terminal window. I love this weather. I love the weather today. It's printed. And also the finish is printed. Now we can have as many conditions as we want. So you know what? Let's add another condition. And we use the elif, and we say if temperature is greater than 10, we want to print it is chilly. And right here, what this condition is saying is that temperature is greater than 10, but also less than 25. This code right here, it is chilly, will be executed. So let's change our temperature to 15. And when we run it, we can see right here it says it is chilly. And after it is chilly, the finished code gets executed. Now let's put a statement that says if the temperature is less than 10, and we want the message to be it is freezing. The way we're going to do that is we're going to type else with a colon, and you can see again we have a new block, we have a new indentation. What this else condition says is basically this code right here that we're going to write is going to get executed if none of these conditions that we have right here are true. Here we can print I am free, I'm freezing. Now we change our temperature to 8, and when we click on it, you can see right here we get I am freezing and then finished. This is how we use if statements to make decisions in our programs. Hey guys, we're talking about while loops in Python. We use while loops to repeat a block of code multiple times. For example, let's say we want to print the numbers from 1 to 10. A poor way of doing this is writing code like this. Print 1, print 2. Come on, see how hard this is? Print 3. Why this is a bad approach is that you see how hard it is to print 10. What if we wanted to print a million or 100,000? Becomes really hard. Just in 5 now. And the task is to print to 10. So we can see already that even for 10, this is hard. We don't want to write hundreds of lines of code just to print numbers. So yeah, let's get this out of the way. And we start a while loop by declaring a variable. In this case, we'll say I, and we give it a value where it's basically going to be its starting point. We start off by declaring a variable called I, and we set it to our starting point. In this case, 1. Then we type while, and after while, we will type a condition. So right now, what is going to be helpful is us using our comparison operators that we learned earlier in this tutorial. Say I less than or equals to 10. And as long as this condition right here is true, then the code that we write in the indentation, in the while block, will get executed. So here we type a colon and we press enter. Now you can see we have a block of code, an indented block of code. In this block, we're going to print I, and after that, we're going to increment I by 1. So we say I equals to I plus 1, or we can do the shorthand, which is I plus equals 1. They're both the same. If we don't increment, I will always be 1. And that is bad because then we're going to get stuck in an infinite loop because this condition right here will always be true. So this block of code right here will always be true and our program will never terminate until it gets out of memory. So in the first iteration, I is 1 and 1 is less than 10. So this gets printed and then we increment I by 1. So then I becomes 2. In the second iteration, I is 2 and 2 is less than 10. And then this block of code gets executed. We first print I and then we increment I by 1 again. Then in this case, I was 2 plus 1, that is 3. So I becomes 3. And now I is 11. And when I is 11, 11 is not less than or equals to 10. So let me show you. Let's run this program. You can see right here, 1, 2, 3, 4, 5 till 10. And it stopped when I was equals to 10. And I hope now you're seeing the beauty and the power of while loops. Because we discussed earlier how we did this without using a while loop and it was stressful. We couldn't even do up to 5. And now we've been able to do up to 10 by just writing how many lines of code? 4. If we wanted to do this the other way, we would have to write 10 lines of code. So that is the power of while loops. And we can even change it from 10 to 1000. And I'm putting this underscore here just to make my code more readable. It doesn't do anything else, just to make it more clear and more readable. And we can see here we printed from 1 to 1000. And I'm sure you'll agree that this is much more easier than 1000 lines of code, each printing one number. Now let me show you something really cool. I'm going to change this to 10. Now instead of printing I want to print an expression. Now, instead of printing I want to print an expression. So I'm going to multiply I by an asterisk. If you're confused here, let me explain. I know earlier I told you that in Python, we cannot concatenate a number to a string. But notice here, I'm using a multiplication operator. The multiplication operator right here is different. We can multiply a number by a string, and this will repeat that string the string right here based on the value of this number right here. If I is 1, we'll see 1 asterisk. If I is 10, we'll see 10 asterisks. Let me show you. Let's run this program. We can see right here from 1 to 10. In the first iteration, I is equals to 1, and I gets incremented by 1 every iteration. And that's why we see that there's always an additional star in every new iteration. Yeah, so you have learned about the 3 types of data types. We have number, which can be integer or float. You have booleans and strings. These are what we refer to as primitive or basic types in Python. Now in Python, we also have some complex types. These complex types are very useful in building applications. In this tutorial, we're going to talk about lists. We use lists whenever we want to represent a list of objects, like a list of numbers or a list of names. Let me show you. I'm going to declare a variable called cars and set it to a list of cars. So here we add square brackets to represent a list. And now we can add one or more objects inside this list. In this list, we add a bunch of car names. So we have Honda, Cadillac, BMW, BMW, Kia. And if you notice, we separate each list item with a comma. Okay, let's print the cars. We put in here cars, and we load it, and we can see it right here. And we can also get the individual elements of this list. For example, if we want to get the first element, which is Honda, we type a square bracket, and inside the square bracket, we type an index. The index of the first element in this list is 0. So when we run this program, we will see Honda, which is the first element in this list, printed out. We can see it right there. Now, in Python, we can also use a negative index. This is a feature that doesn't come with other programming languages. So if 0 represents the first element in this list, then what would -1 represent? -1 represents the last element in this list. But don't take my word for it. Let's run the program and see what happens. Yes, you can see it right here, Kia. What do you think -2 would represent? Yes, you guessed it right. It is the second element from the end of the list. So that would be BMW. And we can see that right here. Now we can also change an object in a given index. If we wanted to change the value of the first index to not say Honda, but we want a better car. So we say, oh, we want a Chevrolet. We can do that by calling the variable name that holds this list, which is cars, and we say the index we want it to be on. We want to change, and we say let that, give it an assignment operator right here, and then we say let it be equal to Chevrolet. Let it be equal to Chevrolet. And we go back down here and we print the list. And now we can see Chevrolet has replaced Honda, which was what we started first in this list. We can also select a range of values. For example, let's say we're only interested in the first 3 names. So over here we put a square bracket, we type a square bracket, and here we need to put 2 indexes. we need to put a start index and an end index. Our start index is going to be 0, 1, 2, plus 1, which makes it 3. So we can get these three values right here. And when we run it, we can see we get the three values. So as we see here, Python gave us the start index 0, 1, 2, but excluding the last index. And a quick note here, this element here does not modify our original list. It actually returns a new list. And to show you that, let's print our original list right after this expression. Say cars. And here we go, we can see that it's not changed. This is how we use list in Python. Earlier I told you strings in Python are objects. An object in programming is just like an object in real life, like your remote control, like your bicycle, like your car. They have certain capabilities. So if you type a string here and you put a dot, we can see all the methods that are available for the string objects in Python. Lists are also objects and they have a bunch of methods for adding items, removing items, and so on and so forth. Let me show you. I'm going to declare a list of numbers and set it to 1, 2, 3, 4, and 5. Now, to add a new element to the end of this list, we can use the append method. And we do that by writing the name of the list, and then we use the append, and then we add 6. Now, let's print our list. And when we run it, we can see it right there. So what if we wanted to add a number to the middle or the beginning of the list? For that, we will use the insert method. And now you can go to view, and right here we see parameter info. This is Control P. So when we're right here, we click Control P. If you're using a Mac, it's Command P. Right here, we can see the value that this method expects. And the first value that this method expects is the index value. The type of this index value must be an integer. Therefore, if I want to add a value to the beginning of this list, put 0 as the beginning index because 0 is the first index. Now, the second value that is highlighted is an object, and that can be t. And what this t means, it can be any type. We can pass a number, we can pass a string, we can pass a boolean, we can pass any type. I'm going to pass 0, and we can see our list has 0 at the beginning of the list. We also have a method for removing items. So let's call remove, and we use Control P to see what we need. Here it says value, the value we want to remove in our string. So let's put 4. We want to remove 4 from here. And we run the program, and we can see our updated list does not have 4 in it. Now, if you want to remove all the items in the list, we call the clear method. And this method does not take any. As you can see, it doesn't show anything. Nothing is highlighted because it doesn't need any parameters or arguments. And we can see here our list is empty. Now, sometimes you actually want to know if a given item exists in our list or not. 2 in numbers. And here, as you can see, we're using the in operator and we're checking to see if 2 is in the number list. So this is a Boolean expression. And when we run it, you can see we get a Boolean value, which is true. If I put 9, we get a false. Now, finally, there are some times you want to know how many items you have in a list. To do that, you can use the built-in len function. The way we use the len function is we print len of numbers. We can see 5. And len is a built-in function, just like the print function. That is why it's highlighted as purple. You can see here's purple, here's purple too. It returns the number of elements in the list. When writing Python programs, there are times where you want to iterate over a list and access each item individually. Let me show you how to do that. I'm going to declare a list of numbers. One, two, three, four, 5. Now, if we print the list, it comes out exactly how we wrote it, using the square bracket notation. But what if we wanted to print each item on a separate line? That is where a for loop comes in handy. Let me show you. First thing we're going to do is use the for keyword. Now we declare a variable which is called a loop variable. And we'll give it the name item in numbers. Next we add a colon to start a block of code. This right here is what we call a for loop. With this for loop, we can iterate over all the items in this list. In each iteration, this item variable is going to hold one value. Therefore, in the first iteration, item is going to be equal to 1. In the second iteration, item is going to be equal to 2, and so on. Now, if we print item and run our program, we see each item on a new line. And now you know how to use a for loop. This is how you use a for loop. Now we could also achieve the same thing using a while loop, but our code would be a little bit longer. Let me show you. We would have to start by declaring a loop variable outside our while loop. Let's say item, we set it to 0. And then we say while item is less than, and in this case we need to find out how many values we have in this list, or how long this list is. Therefore, we use the len function and we put in numbers and then a semicolon and we get the indentation. What we're saying is as long as item is less than the length of the numbers list. Print, now we use the square bracket notation to get the element at this item's index. We say numbers of item. Now we need to increment items by 1. Now let's run this program and see what we get. You can see we get the same thing twice. But I just want to say we could also do it this way, and we could do it like this. Item equals to items plus 1. They are the same thing as we discussed earlier, and we still get the same thing. And we can see here we get the first 1 to 5, which is coming from our for loop, and then we get the second 1 to 5, which is coming from our while loop. And you can see right here the implementation of the for loop uses only 3 lines of code, while the implementation for the while loop uses 4 lines of code. So that's what I said earlier, that it is just more code. And as a good programmer, you always opt for the less code option. In the while loop, in the for loop, we don't have to use the square bracket notation right here. We don't have to call the len function, and we don't have to do an increment every time the loop is run. In this tutorial, we're going to talk about the range function in Python. We use the range function to generate a sequence of numbers. Let me show you. We type range. This is a built-in function, and just like the print and the len function. And we can put a value of 6, and this will return a range object. A range object is an object that can store a sequence of numbers. Let's call this numbers and set it to range. You can see here this is the range object, and in this object we're going to have the numbers from 0 to 6. Now if we print numbers, you can see here we have this here which shows us a range of 0 to 6. And as you can notice, you can see that this is not the actual number. This is just a default representation of the numbers. To see the actual numbers, we need to iterate through this range object using a for loop. In the last video, we learned how to iterate through a list using a for loop, but we can also iterate through a range of objects using a for loop. Basically, we can use the for loop to iterate through any object that represents a sequence of numbers. So instead of printing numbers, we're going to use a for loop. So we say for number in numbers, numbers is our range 6. We're going to print number. Take a look. And yeah, we have that right here. Now we see the numbers 0 to 5. As we can see here, the range of 6 supplies numbers from 0 to 6, but not 6 included. Now if we put a comma and we do 12, what do you think happens? The first value here is going to be considered as the starting value, and the second value here is going to be considered as the ending value, and it is going to be excluded. Therefore, range of 6 to 12 is going to generate the numbers from 6 to 11. Take a look. We can see that right here, 6 to 11. Now we can also supply a third value, and that will be used as a step. Now let's say instead of having a sequence of numbers from 6 to 11, and we do 6, 7, 8, we want to jump to 6, 8, 10, and so on. Here we pass 2 as the step. Take a look at it. You see here we get these even numbers, 6, 8, and 10. Now this is the range function in Python, and a lot of times you will notice that the range function is used as part of a for loop. And that is because we don't need to store the range in a variable first. We can just call it right here. And as we said earlier, the less code we use, the better. So we wouldn't have this extra line. We would just have the range function here instead. Right here, we can type range, and then we put 9, and this will give us a range of values from 0 to 8. Take a look. Therefore, we don't need to store this extra line of code, and we can just have it like this. See, much better. Now we're going to talk about tuples. Tuples are kind of like lists. We use them to store a sequence of objects, but tuples are what we call immutable, which means we cannot change them when we make them. Let me show you. I'm going to start by defining a list of numbers. 2, 4, 6, 8. Now we use square brackets to define a list, and we use parentheses. And we use parentheses to define a tuple. We use square brackets to define a list, and we use parentheses to define a tuple. Therefore, this numbers variable is storing a tuple. It's not storing a list anymore. If we try to reassign the second to 10, we get an error. And we can see here, it shows us where the error is. It says line 2 on our main file. And it shows us the error itself, which is us trying to change the value of the tuple. And it shows us tuple. Object does not support item assignment. And this is what I mean when I tell you that tuples are immutable. And also, if you type numbers dot, you don't see any methods like append, insert, and all the methods we had for the list. We only have count and index. Count right here returns the number of occurrence of an element. For example, we put 4 here and we print. You can see it shows up 1. If I add to this tuple another 4, now you can see we get 2. The other method we have here is the index, and the index returns the index of the first occurrence of the element that is placed in it. Now, these other methods that you see with an underscore, they are called magic methods. This is a little bit more advanced than what we're doing right now. Now, practically speaking, most of the time you will be using lists, but there are times where you will need a tuple. And an example is maybe you create a list of objects and you want to make sure that no one can modify that list of objects. This is where a tuple comes in handy. Yeah, so that's it for this tutorial. Hopefully you learned from it. Hopefully you gained something from it. And if you did, please, it really helps the channel out if you subscribe, like the video, share it to friends that know that would love this kind of thing. So yeah, and I will be releasing a part 2 where we go over more advanced topics like functions and dictionaries and just more advanced stuff. The whole purpose of this is for absolute beginners. It's for people who want to start their journey or people who want to refresh on the fundamentals, the basics of Python programming and actually programming in general. That's why I made this. So yeah, keep your heads up for the next one. Hope you enjoyed it. Please like and subscribe to the channel. It really helps the channel and me out. And yeah, see you in the next video.